So what we have done in the previous lecture was we saw at the variance, started with the variance. The variance is nothing but the mean square deviation from the mean. Okay, so x bar is the mean, xi minus x bar whole square summation upon n. That is a formula for the raw data. Then if it is the frequency distribution, whether it is discrete or it is continuous, then summation fi xi minus x bar square upon summation fi. So it is denoted by var or sigma square. Then the standard deviation is actually the positive square root. Uh, Standard deviation is nothing but the positive square root of the variance, and the formulas are like this. Later, we saw the simplified version of the formula, and it says that you take the mean of the x squares and minus the mean square. Okay, that is the formula for the variance, and the standard deviation will be as the positive square root of this variance. Later, the coefficient of variation in order to compare two group of data, two data given to determine which one is more consistent or which shows more variability. So for that purpose, we define the Carl Pearson's coefficient of variation, and coefficient of variation is given by the standard deviation upon the arithmetic mean into 100. So whichever is having more value or the more percent will show more variability, and whichever is having less coefficient of variation will give us the more consistency. Then the properties, the first property says that the change of origin does not affect your standard deviation or the variance, but the change of scale, of course, it does uh, depend. Okay, so standard deviation of x will be given by h into standard deviation of u if the new variable u is formed by changing the scale of the variable. Okay, and last one was the combined variance and standard deviation. And this is the last formula that we have seen. Now, in today's lecture, what we need to do is we need to go for some examples based on this. So, hopefully, everyone has a scientific calculator with them because we are going to need it a lot. So, example. Compute the standard deviation. Compute standard deviation and variance Oh, sorry, not variance, coefficient of variation. Coefficient of variation for the following data. So 36, 15, 25, 10, 40. First of all, quickly, what is the formula for standard deviation? And the other one, coefficient of variation. Quickly, who's going to answer this? Look, if you don't reply now, then I will have to remove you from the meeting. Anyhow, you are inactive considering that. This is on record, I am telling you. If you are not able to answer whatever you have written somewhere in the notebook, then all the teaching is worthless. Is someone going to unmute and speak up? Or else I'll start calling up the names now. Akanksha Raut. Fine. Apuru Srivastava. If you don't reply, I'll remove you from the meeting. Quickly unmute and speak up. Yes. Ayush
Sir,
Prasad. Huh.
Hello, sir.
Yes.
Sir, I said you my
sir,
reason. Yesterday I was absent, so I do not know when.
Okay. Dhruv Bafna.
Yes, sir.
Yes,
So,
tell me the formula.
so first we have to calculate the mean, and after that subtracting 36 from the given mean, and then squaring it. So 1
Tell me,
36 minus 20 whole
tell me the
square.
formula. Tell me the formula.
So x minus x whole square by
Psi minus
x is bar
x
whole square
bar whole square
by
by n. That's it?
so a summation from I is equal to 1.
Huh. Okay. This is the standard deviation
You get 11.5 root.
under root.
No, I mean I am talking about the standard deviation. We get 11.5 sigma square.
Okay, fine. Parth Ghatge.
yes, sir.
Yes, tell me the another formula for standard deviation which we studied yesterday. Is this the same one that
Sir,
we have studied or there is something else?
sir, actually, I had my CT yesterday, so I couldn't attend the lecture.
Okay. Who else knows?
Sir, can I tell?
Let Khushi speak.
Okay.
Under root summation fi in bracket xi minus x bar whole square upon summation fi. I is running from I to 1 to n.
And that is for the frequency distribution. And the simplified version of this formula.
Okay.
So can I speak?
Okay.
Submission fi xi whole square upon submission fi minus submission fi xi upon submission fi whole square.
And the discrete, not a raw data version of that. We don't need FI. We don't have FI in the given example. That's why.
Sir, can I tell?
Xi whole submission xi upon n square minus submission of xi upon n whole square.
Whole square, xi square. Okay, these are the two formulas under root again for standard deviation. So these are the formulas, okay? So whatever summation we have, so I have summation xi square, I also have summation xi, and what about the coefficient of variation?
Sir,
Standard deviation by
Wait,
arithmetic
wait,
mean.
wait. I had to call out the names anyway. So sigma upon x bar into 100, that will give me the coefficient of variation. Saurav, you want to speak anything?
sir, I just wanted to tell the formula for coefficient of variation. That's
Oh,
only. I got it.
36, 15, 25, 10, 14. So these are the exercise. So first of all, whichever formula you need, whichever you are going to use, the same one, whatever summations you have, you make the column. So we have summation x square. I'm going to use this one. So we have xi square summation. So I'll make the column xi square. Then we also need summation xi, which is already there.
So this sum is 100 of x.
The sum is
100.
100.
100.
Okay. Now for x square, you can go on taking the square of each and every term, or you can simply use the thing that I said in the previous lecture. You enter the formula by pressing alpha, press alpha. Once you press alpha, you have the chance to choose one of the variables. So then choose the variable, will press X. Okay, so whichever button is there, you press X, then you can square it, then you will see the term x square. Once you see this x square on your screen, once your function is entered, then you press calculate. Once you press calculate, it will ask you the value of x. Okay, so you will, after you press this, you will see x question mark on your screen. Then you give the value, the first one, 36, and then press equal to. So when you press
129.
equal to, it will give you 1 to 96.
96.
Yes, sir.
Again, when you press equal to, it will again ask you the value of x. Then you give 15 and you will get
225.
25.
again you will press equal to, so this process has to be repeated. This has to be the loop. So once you see x question mark, you give 36, press equal to, it will give you square. Again you press equal to, it will ask you the next value of x, that is 625, the square you will get. Then
Sir, the total summation is 2532.
9625.
32.
Sure,
Yes, sir.
No, sir.
So it's 2442.
it's 2442.
2442.
It's 2442.
Okay, I hope this process is clear, because a lot of calculations will be very much easier if you put the function. If you have any difficulty, you can ask. Fine, I'll rub this now.
So can we directly, sir,
You can directly do it,
can I
but
ask?
later things will become difficult. Then what you will do?
No, no, sir. I'm just asking that if we know the function and if we
Hmm.
enter it, then can we directly add all these values without entering equal to each time?
There is the summation, but you will have to learn how to use it. I don't have the calci, that's why I cannot explain it step by step. But if it is a theory exam, then of course you will have to go by this way, because in that you will have to show the steps, right?
Okay, sir.
X bar is equal to 100 divided by the number of entries, which is 5. So X bar is 20. Then sigma is equal to under root summation xi square divided by n minus summation xi by n whole square. So this is under root 2442 divided by n, which is 5, minus 20 square. So what is sigma?
Root over of 11.5.
What is the answer?
Root of 11.5.
Tell me the final answer.
20.2.
No.
Sir, 9.4021.
9.21.
Yes, sir.
Point four.
9.40.
This is sigma, the standard deviation.
I have a problem with the calculator. When I pressed 2442 upon 5, it showed a fraction instead of a decimal. It didn't solve it.
Press the double implication button. So coefficient of variation is sigma divided by x bar, which is 20, into 100. So coefficient of variation is
47.01.
47.01. I think 45.21. Check it.
No, sir, it is coming out to be 47.0105.
47.05.
37.2.
47.0.
105.
105.
0135.
Okay. So this is how we calculate whenever we have raw data given to us. Now what we will do is we'll think about the other part where we have the frequency distribution given to us. So the next question. Example. Calculate the standard deviation and coefficient of variation for the frequency distribution. Of marks of 100 candidates. Given below. So we have marks and we have frequency. So marks 0 to 20, then 20 to 40, 40 to 60, 60 to 80, 80 to 100. 5, 12, 32, 40, 11. Now, what are the formulas? Mute yourself, whoever is.
Sir, sigma xi square by n minus sigma xi by n का whole square.
Sigma
Xi square by n
minus
and sigma xi by n whole square.
Okay, this wasn't expected from you, first of all. Anyways, anyone else?
So maybe the second part should be summation xi fi upon summation fi whole square.
Okay. Anyone else?
Sir, summation fi xi square upon summation fi minus summation fi xi upon summation fi whole square.
Exactly. So here we are not dealing with the raw data. Here you have a frequency distribution. So the formula has to be summation. I'll drop this summation fi xi. So whenever we have the frequency, you have to take it into account. The formula is summation fi xi square, I is running from 1 to 5, upon summation fi, I is running from 1 to 5, minus summation xi fi upon summation fi, I is running from 1 to 5, I is running from 1 to 5, complete square. And you have to take a raise to 1 by 2. 1 by 2 means the under root. Coefficient of variation, we already know, sigma upon x bar into 100. So let's start with the example. So we have marks 0 to 20, then 20 to 40, 40 to 60, 60 to 80, and then 80 to 100. What are the frequencies? 5, 12, 32, 40, 11. Now what?
Class marks and their squares.
Eighty to 100. The next one, 11. So the class marks, as there are xi's, we cannot consider this class intervals directly. So we'll have class marks over there. Class marks, xi's. So 20 by 2, 10. 40 plus 20, 60 by 2, which is 30, 50, 70, and the last one, 90. Now what columns do we need? First of all, we need fi xi square. This function we can enter it in the calculator. Xi fi we can enter into the calculator. But before going for these things, we can also think of change of origin and the change of scale. Okay, so I can define new UI because these entries are quite large and we don't need such a large entries. That can be the case, but before going for the change of origin and scale, we'll solve one example by our direct formula, because anyhow your calculator is going to do the calculations for you. So xi fi, first column. So next one, xi square fi. What is summation fi here, as the denominator is there? Summation fi is
20.
100.
it is 100, I guess.
Yes, sir, it's 100.
Now xi fi. So this is 50, 360,
1100.
1600.
what is it?
1600.
1 5
1600, so 1600.
28
00
00
990.
990. Next, you enter the function xi square fi. Look, your column is also reduced now because of your calculator. Things are becoming easier. So try to use it more efficiently as you can. What's the first entry?
500.
500.
10,800. 80,000.
80,000.
Yeah.
Okay.
1,96,000. 89,100.
Sir, but we are doing here okay, xi square into. Okay, okay, sir. Okay.
The summation
5,800.
the first one is 5,800. And xi square fi is
3,76,400.
76,400.
76,400. Now, once we have all the details, we can go for standard deviation. Standard deviation is under root. Okay, let's find out the mean first of all, as we'll need it in coefficient of variation. So the mean x bar is summation xi fi, which is 5,800 divided by the frequency, which is 100. So it is 58. Now standard deviation is equal to under root summation xi square fi, which is 3,76,400 divided by the summation fi, which is 100 minus 58 square. So this is under root 3764 minus 58 square. So standard deviation is
20.
20. Now this is x bar, you have the standard deviation, you have the mean, so we can go for the coefficient of variation. Hence, coefficient of variation is equal to sigma, which is 20 upon x bar, which is 58 into 100. So that is
34.48.
34.48.
48%. So this is with the what we say direct method. Okay, so as I said, we can also do this by the change of origin and change of scale. Let's see what happens. So I'll make a method number 2 and I will do the change of origin and scale. So method 2. So what we have, we have the class intervals. So 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. So immediately I'll write down the class marks here. Class marks is 10, 30, 50, 70, 90. The frequencies are 5, 12, 32, 40, 11. Summation of frequency was 100. Now these are the excise. We saw if we take the excise as it is, so what big numbers we have got. So in order to make it simple, I will define UI as xi minus yes, tell me what I should subtract.
50.
50, the middle most frequency or the observation, sorry, divided by whichever you feel to make it easier. So 50, you can see 10 minus 50, that will be 40. 30 minus 50 will be 20. 50 minus 50 is 0. So better one is 20. You can also do the 10 or 5. So, but you need to take this entry in such a manner that the values will become very small. So the first xi, just 10, 10 minus 50, 40 by 20 minus 40 by 20, which is minus 2. The next one will become minus 1, 0. The next one is 1
1.
and 2. What is UIFI? And the next one I will make UI square Fi. UIFI minus 2 into 5 minus 10, then minus 12. This will be 0, 40, 22. Then UI square Fi. $20.
Yes, sir.
This will be 12, 0, 40, and 44. The summation is UIFI is 40.
40.
UI square Fi is 1 and
76.
how 36. So from look till we are doing the calculation with UIs, I'm going to get U bar, the standard deviation for U, but remember that what we are looking at is the variation for the variable X. So first of all, what is our U bar? U bar is summation UIFI upon summation Fi. This is the formula. So that is 40 upon summation Fi is 100. So U bar is 0.4. What will be X bar? Anyone?
U bar into 20 plus 50.
U bar into 20 plus 50. So h into u bar plus a, that was the formula. So x bar will be equal to 50 plus 20 into 0.4. 0.4 into 20 is
8.
8. So total will be 58.
58.
Similarly, we will find sigma u. The formula for sigma u is sigma u, that will be under root summation u I square fi upon summation fi minus summation ui fi upon summation fi whole square. Let's put the formula of values here. So sigma u is equal to under root summation ui square fi 116 divided by summation fi, which is 100 minus 0.4 square. What is sigma u?
1.
1.
1.
Yes, sir.
Yes, sir. 1.
1.16. Okay. Are you sure?
Yes, sir.
Yes, it is 1. Now what will be sigma x? Now sigma x is equal to, what was the relation?
Sir, H into
H.
sigma u.
So h into sigma u. H is 20.
20.
So 20 into 1. So sigma x is equal to 20. So we have sigma x, we have x bar, and now we can go for finding out. Let's check whether it is correct. So look, standard deviation 20. Here also say standard deviation we have got 20. X bar is 58. By this method also we have got x bar as 58. So now the coefficient of variation. So coefficient of variation is equal to sigma upon x bar. What was our x bar? X bar is 58 into 100. The same answer, which is 34.48. Fine.